How many children per family lead to peace? Most of us have never asked ourselves this question. If we did, the limitations in thought processes, which I demonstrated in the first part of this talk, would produce incorrect answers. So let me ask this question again, this time applying the helper tools related to each of those limitations. Like our initial views of not wearing seat belts and putting our arms out to reduce the injury of our child, the answer to this question, resulting from using coupling, simultaneity, and abstracting nonlinearity, might not be what most of us expect. First, let me define some terms. In this discussion, peace and conflict are not descriptions of behavior between nations. Peace and conflict are trends describing social conditions. Like slower and faster describe trends in an object's velocity, peace and conflict, like non-existing words peacier and conflictinger, describe trends in social conditions. Using this definition, any trend toward peace results in a trend away from conflict and vice versa. The question we are addressing in this discussion, how many children per family lead to peace, is a request to understand what number of offspring establishes a trend toward peace. What number of offspring establishes a trend away from conflict? Let me give a new definition of the word conflict. Instead of having conflict be the violence between neighbors or nations, I will define conflict as the unwanted intrusion of one person's existence on another person. There are two kinds of intrusion. Direct intrusions include he took my tree's fruit, he hit me, he enslaved me, he killed me. Indirect intrusions are the byproducts rather than the intent of other people's behavior. For example, all the trees on the island were consumed by our grandparents is an indirect intrusion of a past generation on a present one. The rich people raised the price of gasoline, and we can't afford any for our irrigation pump, is an economic intrusion of one present group on another present group. All the oil was consumed by our grandparents is an intrusion of the present group on a future group. System conflict is the sum of intrusions experienced by each constituent, summed over all the constituents. A measure of existing global conflict is the sum of 6 billion sets of intrusions. Using this definition of conflict, social systems can slide toward conflict or toward peace. Our task is to describe which choice of children per family moves social systems toward peace. There are forces other than children per family, that is, changes in population, that push social systems toward peace or conflict. For example, institutional, technological, and economic forces move social systems either way. In this model, I have consolidated all these forces into a single force, represented by a change in a single variable. I call that variable well-being. Changes in well-being move social systems toward or away from conflict. If you need a way to quantify well-being, use the difference between a person's attained footprint and his or her minimal subsistence footprint. My goal is to use the model to show that changes in well-being, combined with changes in population, control the movement of social systems toward peace or conflict. The changes in population depend on all parents' decisions to have children. Changes in my well-being variable are determined by all of their children's decisions to increase or decrease their well-being relative to that of their parents. Various combinations of these two decisions determine a system's movements toward peace or conflict. Let me use an island community to demonstrate the validity of this model. On this island, childless couples live on different sized farms and each couple is deciding how many children to have. Obviously, the island population will go up or down depending on the sum of all their decisions. Our goal, after we complete this analysis, is to know the appropriate number of children per couple that will move this island community toward peace. First, two small details. Do all couples on the island have to have the same number of children? The answer is yes. If they did not, it would violate Immanuel Kant's definition of a moral person. A behavior is good if everyone does that behavior and the outcome is still good. After we figure out what number of children leads to peace, anyone choosing a larger number would be violating the imperative or performing an immoral act. The second detail, fertility, live births per woman. To determine future changes in population is usually presented in decimals, for example 1.7 or 3.5 children per woman. However, no woman can have 1.7 or 3.5 children. Therefore, the fertility choice of an individual is one of these integers. Now it's time to apply the three thought process correction tools to this question. That is, they produce the same trend in population and subsequently a similar trend in conflict. Yes, I can couple together all the numbers that create population decline. Both the number 0 and 1 produce a declining population. I can couple together the numbers 3 through 14 children per family because all of those choices produce increasing population. This leaves only one digit on a sign. Two children per family results nominally in population not changing. So using coupling, I have reduced the number of parent procreative choices to 3, each related to one of 3 unique trends in population: down, constant, and up. The coupling tool can also be applied to the other 2 variables in the model, well-being and social conflict. Well-being must be declining, remaining the same, or improving. Social conflict must be decreasing, remaining the same, or increasing. Using coupling, I have reduced the island's variables, relationships, and data to 3 variables, where each variable must be either decreasing, remaining constant, or increasing. The remaining task is to show how these 9 trends interact with one another. That is, we want to know which of the 3 conflict trends result from the 9 possible combinations of 3 population trends and 3 well-being trends. Sounds like a mind-boggling problem where everything is changing at once. Remember how we solved the monk problem using simultaneity? That is, we displayed the data about the monk's 2 trips up and down the mountain on 2 graphs, and then combined the 2 graphs into a single graph to see an easy solution. Now we're going to graph what we know about trends in population, well-being, and conflict on the same page to help us understand how the 9 possible combinations, one of the 3 population trends, one of the 3 well-being trends, establishes which one of the conflict trends. I will start by drawing 9 boxes. I'm going to assign one of the 3 possible population behaviors and thus one of the trends to each column of boxes. Procreation behaviors that make population go down, I assign to each box in the first column. Procreation behaviors that cause constant population, I assign to each box in the second column. And procreation behaviors that cause rising population, I assign to each box in the third column. To allow computation in the island example, I will pick an integer from each group. For example, I pick 1 kid per family for the possible declining population behaviors, 2 for constant population behaviors, and 3 for rising population behaviors. We can get a measure of change in well-being by comparing the well-being of the parents to the well-being attained by their offspring. On this island, the parent well-being is land. So the kids' well-being is either more land than their parents, the same land, or less land. I have used the numbers 1.0 to mean the children attain the same well-being as their parents, 0.5 to mean the children attain half of what their parents had, and 1.5 to mean the children want 1.5 times the land their parents had. Now we can calculate, by multiplying the row and column numbers of each square, the total land required by a parent's offspring. For example, if the parents have 2 kids, and each wants the well-being that their parents had, 2 kids times 1 unit of land equals 2. 3 kids with the same needs as their parents results in 3 land units being required. 1 kid needing 1 unit is 1. 1 kid with half the needs of his parents equals 0.5. 3 kids with 1.5 times the needs of their parents requires 4.5 units of land. I think we can fill in the rest of the numbers that reflect the land requirements of a parent's offspring. It is not the amount the kids require that raises or lowers conflict. It's the changes in attainment relative to what the parents had that does so. With the parents willing their kids 2 units of land, the number that causes a change in conflict is the number of units in each box subtracted from the 2 units inherited. For example, when 2 kids each need 1 unit of land well-being and their parents will them 2 units, then the contribution to change of well-being of anyone outside themselves is 0. When 3 children want 1.5 units of land, or 4.5 units total, and their parents will them 2 units, they will need an additional 2.5 units. The minus means that these kids, to meet their land requirements, will have to take 2.5 units from other kids on the island. Any square where the number is bigger than 2 will require that the kids do some taking. All the squares where the numbers are less than 2 will allow the kids to do some giving. For example, 2 minus 1.5 units, a situation where between generations 5/10 units of land is released. This is a table of the land movements between generations. Negative numbers mean the children will need to take land to achieve their well-being requirements. I will change their labels to take and their color to red. Positive numbers mean the children will give land to achieve their well-being requirements. I will change their labels to give and their color to blue. 0.0 in the center box means the kids will neither take or give up land to meet their requirements. If conflict is defined as the intrusion, even if it's caused by benign economic transaction, then taking means increasing conflict, and giving means decreasing conflict. When takes or gives are converted to increasing or decreasing conflict arrows, the resulting 3x3 graph connects the trends in children's well-being, the trend in population, and the trend in conflict in the same way as the 2 maps of the monk problem laid on top of one another. The graph shows the resulting 3x3 graph connects the trends in children's well-being, the trends in population, and the trends in social conflict in a similar way as the 2 maps of the monk problem laid on top of one another. The graph shows the trend in well-being and the trend in population contribute to control the trend in conflict. The graph creates simultaneity among the conflict trend and 2 behaviors. The parent's procreative behavior and the children's behavior to attain well-being. The parents choose their procreative behavior first, the children choose their well-being behavior later. Parents have to choose 1, 2, or 3 children per family before they know whether the children will choose less, the same, or more well-being than their parents. Let's test the three alternative parental procreative behaviors to see how they affect the conflict trend. If parents choose 3 or more children per family, and the children want to consume the same or more than their parents, I am referring to the 2 red squares in the highlighted column. The parents, at least on this island, have to take responsibility for increasing conflict. If parents believe their kids will consume a smaller portion of the supporting resources than they themselves consume, the bottom blue box in the highlighted column, I suggest they believe in fantasy. At least in our community, a child may want a smaller car or home, but I don't think they want less education, less food, less health care, less retirement, or less vacation. I think, in all fairness to rationality, if the parent wants less conflict, he or she cannot choose 3 or more children per family, at least not on this island. So let me blank out having 3 kids per family and consider the parent's choice of just 2. We have already discussed that the red squares produce ever-increasing conflict. And we have outlined the unlikely possibility that children will actually reduce their footprints below what their parents had. However, we have not discussed the white square in the middle of the center column, the one that displays a horizontal arrow, which indicates constant conflict. It almost looks like a viable solution until one realizes that if everyone takes it, it will not produce universally good results. Some people will be locked into today's poverty and conflict. For example, yes, you can keep your SUV if you are willing to lose a few kids in Iraq. And yes, if you are willing to live in a continuous civil war in Somalia. If parents want their choice of children to create increasing peace, 2 children per family will not produce it. If parents want to choose a number of children per family that will produce increasing peace, that is, decreasing conflict, they must choose the only remaining alternative, 1 child per family. So now you have proof that increasing peace requires a 1 child per family behavior. All the other choices lead to increasing conflict. I don't think this proof is strong enough to change anyone's behavior. We gave this kind of proof to people in 1968 to wear their seatbelts, and they didn't wear them. Each individual had irrational reasons to justify not wearing seatbelts. Today, each parent also has irrational reasons why it is not necessary to limit him or herself to only 1 child. Look at the list. Only children are spoiled. Children deserve my love. I can afford them. The Social Security system needs youth. Economies need children for growth. Our competitors will outnumber us. Furthermore, individuals who want more than 1 child will look at the red, white, and blue boxes in the graph and believe that generosity, compassion, recycling, and conservation will create and maintain a peaceful community. They will believe technology will provide the extra goods and services to prevent conflict. You may question the intensity of my worry. You counter that the human community has weathered wars and deprivation many times and has muddled through. You believe that we'll muddle through this time too. What if I can show you that we have as much chance of muddling through the coming world crisis of conflict as we have of not being injured in an unbelted car crash? To prove this point, in the next section, I will apply the third tool, abstracting nonlinearity, to the children per family choice problem. Maybe it will show why most people today will ignore the 3x3 proof just like they ignored the proof that seatbelts save lives. Maybe you will see why I am so worried and most people are not.